An isosceles trapezoidal water trough, 10 meters long, 3 of the 4 sides on its trapezoidal face has a length of 30 centimeters. The 2 slanted sides of the trapezoid make an angle of theta with the 30 centimeter base. What should angle theta be in order to maximize the amount of water this water trough holds? So we're trying to maximize the volume. The volume of this water trough would be 1 over 2 base 1 plus base 2 times length times height. Alright, times height times length, where this is the length. Instead of 10 meters, I'm going to make the length as 1,000 centimeters. The reason I put centimeters is because the rest of the measurements are in centimeters. This is the height, this dotted line, and this is the base 2. This is the base 1. So we don't know the base 2 and we don't know the height. So what is the base 2? We can find the base 2 and the height by creating a division here. The goal of the question is to find the angle that maximizes the volume. So we need to incorporate an angle somehow in this formula. This theta cannot directly help us, but this angle over here, x, can help us. So how can x help us? The relationship between x and theta is this. A quadrilateral has to add up, all the angles in a quadrilateral have to add up to 360 degrees. This trapezoid faces a quadrilateral, so 2x plus 2 theta is equal to 360 degrees. Since this is also theta, and this is also x. So basically theta is equal to 360 minus 2x, which is 180 minus x. So this is the relationship between theta and x. Now how will theta help us? Since creating this division makes a right angle triangle, the opposite side to x is the height. So we can denote the height as 30 sine x. And then there's this subsection, and there's this section too. And these two lines plus 30 makes up the base 2. So we'll do base 2. We'll make these two lines as n. So base 2 is equal to n. 2n plus 30, where n equals to this is adjacent to x, so n is equal to 30 cos x. So b2 is equal to 60 cos x plus 30. Now that we have base 2 and we also have the height, we can plug it into the volume equation and then try to maximize the volume. Now that we have a simplified volume equation, we can find the derivative of this. Now we got a sort of quadratic formula. So I can set cos x equal to w and then use this to factor and now we found the x value, which gives us the highest volume, but that's not what we're looking for. We're trying to find the angle that gives us the highest volume, angle theta. So we'll plug in the x, so 180 minus 60, which gives us 120. So that's the answer. If you did it in radians, you would get this answer, but basically 2 pi over 3 radians is equal to 120 degrees. So thank you.